Hello, everyone. Thanks for coming to Shopee for this meetup. I'm Frank, contributor of ClickHouse and computer of RPG Suite and PMC member of RPG Suite. The topic today I'm going to share with you is about the distributed tracing in ClickHouse. That's the work that we have been done in the past few years. There are 4 parts of the talk. The first is background, and the second is some basic understanding of distributed tracing if you have never heard of it. Next is how we implement distributed tracing in or upon ClickHouse. And last is some cases. In Shopee, we started the ClickHouse service 4 years ago, and since then, ClickHouse has become the first choice of our data applications. So there are a lot of use cases. I think the use cases you can find in the industry can be found in Shopee too, from the anti-fraud detection or to the log storage as well as replacement to the identity search and MySQL. In Shopee, our internal service is mainly consists of 5 major parts. The first is a ClickHouse manager, which is responsible for the resource application and cluster deployment. The second one is ClickHouse gateway. Gateway is the entry for all the incoming queries to our ClickHouse cluster. And the third part is ClickHouse console. ClickHouse console is a web-based application that allow us to run queries and ad hoc queries from our local computer without install any clients. And the core of our service, we provide different kinds of ClickHouse clusters based on user needs and the hardware machines that we have. Last part is ClickHouse monitoring. ClickHouse monitoring we can see it is provides the observability for our whole service, and the distributed tracing is also included in the ClickHouse monitoring part. As we serve hundreds of internal projects and hundreds of users. So every day we receive a lot of questions from our users. So some of our questions are very easy to handle. If the query comes with an exception, sometimes we can tell the root cause based on the exception code returned from ClickHouse server. But for many questions, it's not easy to answer what the root causes are. We have to collect as many information as we can so that we can make a judgment. So for example, if the problem is related to a latency problem, we have to know when the query comes up and our ClickHouse gateway side, and when the gateway issued the query to our ClickHouse cluster side, and when the subquery arrives at the ClickHouse replica. So then we can judge whether this latency problem is about the ClickHouse gateway or certain replicas. For query failure, sometimes we have to know whether this exception is from the ClickHouse gateway side or from particular ClickHouse replica. So to answer these user questions, we have to collect all the information that we can to make a judgment. So this is why we started to implement distributed tracing internally, because distributed tracing has been proven to be a powerful tool in the distributed applications. If you have never heard of distributed tracing, there is a very simple application so that you can understand what it is. Say there is a query on the distributed table. Goes into the gateway, and the gateway will forward this query to our internal ClickHouse replica. And this replica SHA-1 will issue a subquery to the SHA-2. From the gateway side, the response goes back to the client, user client when the whole processing is completes. So the gateway can record some information like the URL that it receives and when the query starts and the duration and the gateway side. so that the ClickHouse shadow one, for example, if it can record some information about when it issues the internal queries to the next replica. And so does the ClickHouse shadow 2. But the question is, in the traditional way, this information is scanned across these different applications. If we sorry, what is? Okay. We can tell which information is associated with another information in the distributed network. So to solve this problem, then the distribution is introduced. Let's say in the distribution, there are some concepts like spans. We just define this kind of logs or whatever, anything as a span, and there is a unique ID for each span. Let's say there are three spans for the 3 different logs from the 3 applications. But to make sure we know that the information are associated together, we need another thing to do that. That is comes with the tracing context. Tracing context is something that we define for each request from user side. And we will assign a unique identifier for each request, and that is generally a trace ID. And inside the tracing context, there is some actual fields like parent or span. These 2 fields tell us what's the relationship between the span logs generated between applications. During the processing of a request, this trace context will be propagated to the next nodes in the network. For example, when the request is issued from gateway will carry this tracing context in its request to ClickHouse shadow 1, and shadow 1 will do the same thing. So when we have such information and these logs are collected together, and we can save this information like a table, or save this information like any database we like. But the key point is that there are 3 columns. The first one is the trace ID. The second and third one is parent span ID and span ID. These concepts tell us what's the relationship between and what's the relationship in a trace for specific trees. So once we know the trace ID, we can search the result from the table. For example, let's say we want to search the 1, 2, 3, 5 to 8, and there are 4 logs from this table. And because of we know the relationship between each logs, we can form these logs in a tree style, and it will tell us how the process is processed in the distributed network. So about the distribution, there are some protocols define how the tracing context is defined. There are some protocols like Zookeeper and Pinpoint, which are very popular in the Java world. And now we are using, and I think the OpenTelemetry is more popular because it has been a W3C standard. So it just defines HTTP header as transparent, and it has a format of how this protocol is defined. It has and the first 2 digits is the version, and the next 32 digits is unique trace ID, and next 6 digits are span ID, and last 2 flags. So we can follow this format to process the protocol and make sure that tracing context is propagated correctly. So these are the basic information of distributed tracing. What we need to do is to make sure the tracing context is correctly processed or propagated to the next node in the network. So let's see how we do it in ClickHouse. Here is the high-level view of our solution. The upper part of this picture is our service, What the difference is that you can see that in the ClickHouse gateway, there is a Java agent that is responsible for the tracing context initialization. It will create a tracing context for each queries, for each query that it receives. And this kind of Java agent can also be deployed on our client-side application if it is a Java application. And the gateway will be responsible for propagation the tracing context to the ClickHouse clusters. And the distributed tracing logs generated by ClickHouse will be connected to our centralized connector for further processing. And finally, we will use ClickHouse to store the logs generated by our service. But note that the ClickHouse used for the storage is a different cluster from the clusters we provide to users. So in ClickHouse, there are some challenges to implement such a feature. The first one is because it's a C++ application, we cannot use the Java agent for us to do the tracing context propagation. So we have to do it by ourselves from scratch to carefully handle the tracing context propagation across threads. And next is then in ClickHouse, there are many async processing like async insert and unclass DDR. They are totally different async processing. The last part is the distributed tracing will generate lots of very huge data, and we have to process it in real time and finally store it in a good place. So let's the work started about 3 years ago, and that time the feature in the ClickHouse is just a prototype. It does not work. So we rework all the work, rework the whole feature in the ClickHouse and make it to be a production-ready feature. And now it's a mature feature, I think. And all the work that we have been done have been contributed back to the community. I think you can benefit this feature from the open source community. As I said before, the main challenge in ClickHouse to do so is make sure the tracing context is correctly propagated across threads and across ClickHouse nodes. The first is about how we handle the tracing context across internal jobs. For what we do is when a query comes into the ClickHouse, and the HTTP handler then is responsible for handling the queries in HTTP threads. What we do is whenever there is a job forked from the HTTP threads, what we do is if there is a tracing context associated with the thread, we will copy the tracing context information to the job and keep this information along with the job in the job queue. So when the job is fetched by a thread pool, and the thread pool knows that there is a tracing context associated with that job. So if there is one, it will restore the tracing context on that thread and do the following processing of that job. And when the job is done, the tracing context on the particular thread will be destroyed. For the async insert, the things is different because ClickHouse uses disk files for data swapping. So when an insert comes into ClickHouse, it will first split the data according to the sharding key in the distributed table and save this data in files too. So what we have to do is make sure the tracing context is correctly saved, and so that in the future processing we can restore the tracing context. So in this case, we keep the tracing context in the file. And when the background description thread read the data from a file, it knows there is a tracing context, and it will restore the tracing context on that thread. And when it sends out the data to another shard, the tracing content will be sent to the shard with the data too. And this is an example that shows from our log that shows how insert on distributed table and how many shards are involved in this insert and how many those per shard is written to. Or for the unclassed DDR, things are different too, because in this case, Zookeeper is involved. We do the similar thing, that is to keep the tracing context in Zookeeper. And when the background DDR thread feeds the information from the Zookeeper, it knows whether there is a tracing context kept in the Zookeeper. If there is, it will restore the tracing context too. And the next is the same. So this is another example from our logs several years ago, and we can see from here that several nodes are involved in the processing, and we know when each node processes this request. Above is how the tracing context is handled inside ClickHouse. And after that, what we need to do is make sure the data can be exported from ClickHouse to our centralized collector and for further processing. In ClickHouse, we provide a system table. System table in ClickHouse is a kind of a table that allows us to save some internal states of a ClickHouse. Like there are query logs or crash logs. So we do the same thing. When the distributed tracing logs are generated during the processing, they will be first written to a memory buffer, and ClickHouse will periodically flush the data in the memory buffer to the system table. And we use a materialized view as introduced by Derek before. It will be triggered whenever insert on the system table. And this particular materialized view will read will write the data to a specific ClickHouse URL table engine. You can see this URL table engine in such case is just a HTTP client. It just format the data in a format that we want and send the data to our centralized connector. No, we don't use OpenMSI connector. Because 3 years ago, it's not mature. Yeah. For the log processing, there are several parts are involved. The first is data normalization and the data sanitization. Because we know that we can put the password in the URL to send to ClickHouse. If this information are kept in the logs, and they are sensitive information, we have to sanitize the information. And we also have some metrics depends on the distributed tracing logs, and then mapping, indexing, and last is store. What I want to mention is about mapping, because we know that we generate a unique trace ID for each request, but this ID is not visible to users. Users only knows their query ID. They don't know the trace ID. So how do they find the trace logs for their each request? So what we do is, because we know if there is a query ID in the distributed trace logs, if there is, we will associate that particular query ID and the trace ID and store them together in the ClickHouse. So if user query logs, whether it is a trace ID or query ID, we will first try to find it in the mapping table. If there is a mapped entry, we can use the saved trace ID to query the logs too. As I mentioned before, we use ClickHouse intern to save the distributed tracing logs. The reason that we choose ClickHouse is that the first is for the higher compression ratio. We know that ClickHouse default use as4 for compression, but in our case, we use ZSDD for better compression and to achieve lower disk cost. And ClickHouse supports higher throughput for insert because we generate very huge data during the log queries. But ClickHouse supports a very large batch. And typically, we insert per 300,000 in just one insert statement. In our peak time, we can handle 3 million of those per second in just on just one machine. And also, ClickHouse support hybrid disk. So then we can store the latest two data on the SSD for better query performance. And the ClickHouse will automatically move the outdated data to our HDD disk. The last one is sometimes we also want to analyze our query logs, analyze our distributed tracing logs. So because ClickHouse also provides better analytic support, it is a very natural choice to use ClickHouse to serve that need. Last part is, as I said before, the trace ID is not visible to users. And sometimes the query ID is also not visible to users. If you are using JDBC, JDBC does not allow you to set a query ID for each request. So how do the users know the query ID and the trace ID? Actually, they have no idea. So what we do is we do some trick. For example, for the if there is an error comes from the ClickHouse, we know and we have a ClickHouse gateway before the ClickHouse, and the ClickHouse gateway is working on the layer 7, so it knows what is the response then the ClickHouse returns. So when gateway knows it is exception response, our gateway will automatically change the response and inject the query ID and the links of the distribution log to the response. So user will receive the whole error message. So whatever the client and the user use, they will receive such error messages. So then user knows what is the query ID and where is the link, then he can check the logs. It not only helps us to save several times to communicate with users, what is your query ID or trace ID, but also saves a lot of user times to check where to find the trace logs. Another point is we can in our platform we can search the distributed trace logs by very complicated expressions, but users don't know how to write that complex expression. What we do is we do this for users. How do we do that? Users can we provide metrics for users. And if users are want to know what if the users want to know what happened when this error picks, he can check the distribution of the errors. And if the users want to care about this exception, like the first row, then show the exception code is 41. He can click the trace log button, and our platform will automatically generate a complex search expression for users, so that users don't need to do that by themselves. By this way, users can check what happened during this time and what is the specific query during this time. So then that's some work that we have done in the ClickHouse, and there are some very interesting case. Then we have never expected that tracing can help us to resolve these problems. For example, the first of all, sorry, there might be something wrong with the. I think there might be something wrong with the slides. Okay. The first thing is we can see that the response time is about 118 seconds, but we don't know what happened. So by using the distributed tracing log, we can know that the time is mainly spent on the ClickHouse gateway side, not on the ClickHouse side. So we can judge. First, we can narrow down our problem scope. But even for this problem, actually, it is not the problem of the gateway, but it is because the client then sends data to ClickHouse in a very slow way. So the how we solve this problem is just to ask the user to enable the data compression and the client side to reduce the payload of the request. Another very interesting problem is that we received feedback from users, then they see the response from the ClickHouse is different. So we check the logs and find something very interesting. Then you can see here, the request is going to be the shard 041, but by the logs, it is the shard 02, then receive the subquery. It shouldn't happen, right? It should be the shard 041, then receive the subquery. So this problem turned out to be a DNS cache problem in the Kubernetes. And and we know that in ClickHouse, the distributed join is very complex. It provides a setting for users to change the behavior of ClickHouse, but it's very hard to explain what it is for users. But by the distribution, and this is a graph showed from the distribution log, users know how the distributed join is executed in the ClickHouse. For example, if this setting is set to allow, the ClickHouse will issue many subqueries. However, if this setting is set to global, the query is much simpler and much more performant. By this way, we don't need to write a very detailed document to users to explain how this setting works. And this is for how it helps us to resolve the unclassed DDR timeout. It is a very common problem in ClickHouse that DDR, then the DDR timeout. By checking the logs, we know that the ClickHouse actually received the query at this time, but one node will process this request just about one minute later. So then we know there is something wrong and this particular node. So we can check the query logs and some other information on this specific node to find more. So actually, in such case, it should be some other DDR blocking this one. We just want to find which one blocked this one. The next is about the multi-last view. As we said before, multi-last view is triggered when an insert comes to the source table. But in many cases, users, because of a project transfer or new users joining a team, many members don't know much about the multi-last view. So sometimes they may ask, why does my insert fails? And then seeing something that is totally have no relationship to my insert target table. So in this way, we just do check the distribution logs, because this log will record whether there is a multi-last view triggered during the insert. And if there is one and any exception through from the multi-last view, from this log, we know that there's something wrong inside the multi-last view. So users can check why there is a multi-last view, how this multi-last view is used, why this error comes from the multi-last view. Okay, that's all from my side. And in recap, we do something, we implement the whole distribution feature inside the ClickHouse. And in turn, we use ClickHouse to store the distribution logs generated by ClickHouse itself. It's a very interesting thing. And okay, any questions? You mean the sharding key in my previous example? Yeah, it's a random. It's random. Mm. Yes. It comes here actually, and we as how we choose ClickHouse and the store engines. I think this answers this question. We know that Java uses Elasticsearch and some other tools like Pinpoint uses HBase. But for HBase, it's very painful to maintain a HBase cluster. There are name node, data node, and Zookeeper is very complicated to set up a cluster. But in ClickHouse, it's just a binary. In our case, there is just one machine. We don't need to set up a cluster. And for ClickHouse, for the ES, the point is, ES is also takes for lots of resources, especially when we want to insert data to ES in a very high throughput. So that's why we don't choose ES and HBase and the storage. And because of that, we set up the whole processing pipeline on ClickHouse. And actually, we have some other use cases to replace ES, such as in the login scenario. If there is going to be another meetup in future, I think we can share more our stories about that. Are you also able to identify if the Zookeeper or the ClickHouse keeper is not? No, no. Because to do that is the first one is in our experience, we have never encountered any issues between ClickHouse and Zookeeper. The second one is the protocol between ClickHouse and Zookeeper is a private protocol. It's very hard to inject the tracing context in the protocol. So things are different for HTTP protocol. It's very easy for we to put a header in the HTTP. Sorry, could you repeat again? Optimized frames. Those that doesn't follow the best practices, putting back the customer, or use the same frames. Yeah, yeah. We do guide users to optimize their queries if we from the sometimes from the distributed tracing logs, but I didn't show the case here. Because every day now, every day when user feed send us a problem, we'll first check what happened in the logs. If there is some bottleneck or it takes very long time to process inside ClickHouse, we will check what is the query, what is subquery, and if there is a way to improve it. Yeah. No, because as I said before, they are working on the Elasticsearch. So what we do is build a platform by ourselves. But as you can see, then the UI is not very complicated. It's very simple, but it shows all the information users care about. Yeah, open industry is popular in recent. Yeah. Yeah. OpenNet is popular in recent years. Also, how do you propagate the context for the server? No, in ClickHouse, the tracing context is defined in the TCP protocol. Yeah. So it has the trace ID and parent spy ID in the TCP protocol, so that we can trace the subqueries. Yeah. Yeah. Yes. it has also been contributed back to the ClickHouse. You mean the TTR in our case? Generally, because the data volume we now is 5 days, and 5 days for us is enough.
All right, just want to say thank you, everyone. Thank you to the speakers. Thank you for attending today. We're going to hang around a little bit, but please join some of the community Slack, some of the community pages. I just had a quick look. There's almost 7,000 community members on the Slack channel, which is great. We're constantly answering questions as well, so please jump on and feel free to reach out to us. If anyone wants to speak at a meetup in the future as well, please let us know. We're definitely going to come back and have more sessions for ClickHouse users in Singapore. And yeah, so we're going to hang around a little bit more. So thank you very much for your time and Shopee for hosting as well. So thank you, everyone.